What a time to be a programmer, huh? At the start of 2025, AI just seemed to me like the latest entry in a long line of Silicon Valley hype cycles. Seemed to be like where the blockchain fallout was going to head next. By the end of 2025, it kind of seemed undeniable that somehow this was going to change the way we all work. And fast. Really fast. I mean, like the World Wide Web. That changed the way everyone works, but it took a couple of decades to diffuse in society. AI speedrunning it, I think it's going to change things massively within a year or two. So how do we keep up? Specifically us techie types, because personally I think we will all still have jobs in 12 months, but only if we adapt, because they won't be exactly the same jobs. I'm sure of that. How do we keep up? That's a question that's been on my mind a lot lately, and it was particularly on my mind when an old colleague of mine announced that he published an AI tech radar, 68 technologies in a PDF, all from the AI landscape, and it's an analysis of what's hot and what's not, what's worth using, what's worth experimenting with, what should probably be dropped now. Specifically for all of those of us who are trying to get stuff built amid this time of change. So this week, Henry Garner joins me to discuss not all 68 technologies, it's not that big an episode, but some big swathes of it. We managed to go through things like the impact on jobs and the impact on people paying for those jobs, the people paying our salaries. The current debate at the moment, which seems to be MCP versus skills, and is MCP dead or not? Fine-tuning, is that still worthwhile? Frontier models, can you compete? Neurosymbolic AI, what is it? And why does it possibly mean the comeback of Prolog? And how that all leads into a new language that Henry's co-authored called Allium. Now, I have to confess something to you, and to you, Henry, if you're listening to this intro. I didn't get Allium at first. At first, it sounded a little bit like a way to generate more documentation that no one's actually going to read. But I was wrong. The penny drops during this conversation, and I get it now. And I'm going to talk a bit more about it at the end, because I think he's really onto something. But that's towards the end of the conversation. We best get there. We best get on the map and fire up the AI radar. So, I'm your host, Chris Jenkins. This is Developer Voices, and today's voice is Henry Garner. Joining me today is an old friend of mine, Henry Garner. Henry, how are you?
I'm very well, thank you, Chris. Thank you for having me.
Oh, thank you for coming. You, possibly, I've got to get you on the most difficult topic to pin down at the moment, but we must try.
Yes, you've invited me on to talk about this sort of niche interest that I've got. So thank you very much.
This niche field that no one else is talking about.
Yeah.
AI. I think I'm going to rush this episode to production because it's moving so fast, right?
Yeah, I mean, it's dizzying. The pace of change, even when, as I'm basically paid to try and stay on top of these things, is dizzying and overwhelming. The scope as well is absolutely massive. Of course, for us in software engineering, it's changing the whole way we work. But of course, it's reaching out into basically every corner of our lives as well.
Yeah. The thing that stunned me is my wife, who is not a technical person, is using AI every day for her job. It's like, okay, this is a bit like the internet in that it's changing the lives of non-technical people too. But it's going so much faster than the internet dispersed through society, right?
Yes, faster. I sit in the park, people walking past, I can hear talking about Claude, and I know exactly what they're talking about. My wife as well is using it for all sorts, personal correspondence, but also creative pursuits. It's a fantastically versatile tool, no matter what you do, really.
Yeah. We are going to have to talk about the tech of the tool and specifically advanced techniques. But before we get to that, I'm going to have to ask you, because one of the big questions at the moment is how is it going to affect our jobs, right? And you work for, I'll paraphrase the business model here. You work for a company that is basically coders for hire, right?
Essentially, yes. Very
Overflow
good coders with a
code.
lot of domain expertise.
Excellent coders, sometimes including terrific coders who later go on to host a podcast. Lovely agency. I've worked with you in the past. But you must be seeing the blunt edge of this, right? If companies are adopting AI and if jobs are at risk, I would have thought an agency, coders for hire, is the first place that sees the pain of the job market. Is that actually your experience?
Yeah, I mean, what an exciting time to be doing what we're doing.
Yeah.
And I feel the responsibility keenly as the CTO of JUXT. We see it from a few different perspectives. We've got about 150 engineers skewing towards senior engineers who've been doing the job for a while. And they have built up considerable expertise in, if you like, the old way of doing things, hands on keyboard writing code in
lines
IDE.
of code.
And so to see close up what effect this new wave of AI tools, particularly the ones which have landed since late 2025, is having, is fascinating. And there's this quite predictable journey that our engineers are going on from, skepticism and a little bit of resentment. We've all seen hype cycles play out, and plenty of us for some length of time have been saying, basically this will all blow over, or it's spicy autocomplete.
I was saying exactly that a year ago.
Yeah,
and the scales fell from the eyes.
It's a well-trodden path through to, oh my goodness, when you actually get your hands dirty and you start trying out something like Claude Code, for example, is where I am lately advising people begin. Suddenly you realize the power. And I've heard that some people have a bit of a wobble at that point and think, oh my goodness, what these skills that I've spent decades building up, what are they worth now when I can just ask a machine to do the job for me?
Yeah.
That may take a week or two to play out.
I think it was exactly 2 for me.
There you go. Through to the other side, where you realize that it's not taking away your engineering judgment. It's not replacing the things about the role that you enjoyed. It might, in fact, be allowing you to delegate some of the boring drudge work that you used to tolerate, because what you really enjoyed doing was solving big, gnarly problems or thinking through nice solutions. And those solutions have changed shape now. We might not be specifying the precise implementation if we're delegating a lot of that to agents, but you've still got to design what your software needs to do, and you get the payoff of seeing that it's solving real problems and enabling people to do things that they couldn't do before. It's massively accelerated that path to done.
Yeah, I totally agree with that. And I've had great fun. Like all those tiny side projects that I'd never get around to in the past, but would like to build, are things I now tick off of an evening. Right? I've built so many new small projects that are just like scratching personal itches. That is a joy. If you got into this to build things, it's a joy. What I wonder is, let me ask you 2 things about this. So one, have you found like massive resistance from any corners? I would have thought there are some people who jump into this with enthusiasm and some people in your team who are holding out almost to the point of being left behind.
Well, I mean, there's definitely a spectrum. There's a kind of bell curve. And part of my objective over the last year or so has been to ensure that I shift the mean in our organization towards adoption, because the writing's on the wall as far as I'm concerned. This is the new way that software is going to be built, and the era of humans writing code for most projects is over. So you've got to get on board. Of course, there are contrarians who are going to point out all the things that AI can't do. And the story's been the same since the beginning, really, where you point out some ceiling of AI capabilities, and the next model, that's the floor. of their capabilities, and so on. So, those people are a fastly diminishing group of people. But there are some areas where they are right. And it's to do with clear specification of intent. And this is really one of the skills that as engineers, it's one of the core capabilities that we really always had to have, understanding what you're trying to achieve and making sure you're communicating it clearly. I think it's even more important now with agents doing a lot of the implementation.
Yeah.
But contrarians might point out that contemporary models, very smart as they are still kind of constrained by the fact that they are auto-regressive, one token at a time kind of engines who aren't doing real reasoning. And it's they are right to a point, and it's worth bearing that in mind because it does inform why they do some really wacky things sometimes, and it's important not to be completely blindsided by that kind of behavior, where you've got a machine that is, for the most part, highly capable and writing, to be honest, better code than I ever did. But there are going to be occasions where something really strange happens. And so, those contrarian voices have something. I just don't think that is, it's not that interesting to dwell on that right now as the primary takeaway. But from a kind of security and reliability point of view, I think we've got to remember we can't be naive and too breathlessly enthusiastic. It's important that we remain engaged in the process and able to validate that what we're getting out of these agents is indeed what we want. And if we're taking that code through to production, we remain accountable for what happens.
Yeah. I think this is the difference between vibe coding, where you almost wantonly take your hands off the wheel, and what we as professional programmers should be doing, which is more, I tend to use the phrase delegated coding, where we're still expecting to check the final architecture and output. Maybe not. I mean, what do you think? Maybe not reviewing individual lines of code anymore, but certainly reviewing processes and architecture.
Yes. I mean, if we're quite honest with ourselves, were we always reviewing every single line of code that went through our PR review cycle? Maybe not. What you developed was a sense about when you needed to lean in and pay close attention because code was maybe touching something very sensitive. Maybe there was some security angle, or maybe, we do a lot of work for banking and capital markets clients. So there's a regulatory angle. You want to pay close attention in those kinds of situations, but you develop an intuition for when the blast radius of a potential issue is small, maybe the impact's going to be minor. You might not be, stepping through line by line. You mentioned vibe coding, and it's not a term I particularly like because it implies sort of recklessness, which I think is unwarranted. I think it's possible still to introduce a larger distance. This is the metaphor that I like to use between the code and yourself. And as long as you are exercising some good judgment about when it's okay to have large distance between the code and your original prompt, you are not vibe coding. You're simply making good use of your finite attention. And as long as when something is critical, you've got small code distance, then I think, you are remaining responsible.
Yeah. There's an analog there, I think, for unit tests. I've never been a person that aims for 100% coverage. I aim for 100% coverage on the stuff that really matters, the critical stuff. And maybe it's something like that. The distance between my tests and my code sort of matches the distance between me and the code written for me.
Yes. Yeah. I think that's a great analogy. And no check is ever perfect. Our code contains bugs. We might have kind of static analysis that will fix some things, but not all. Then you've got unit tests, and you've got integration tests, which will test the boundaries that the integration tests missed. Like by stacking up these layers, there's a sort of Swiss cheese metaphor where what you want to ensure is that your holes don't line up and that a bug can't make its way all the way through to the end to production.
Yeah.
And the more kind of imperfect, probabilistic gates that you have, the less likely that is to happen.
Yeah, I think that's. I like that image. I've not heard that one before. Let me ask you this then. So, I'm not a static dynamic typing zealot, but I do tend to lean towards statically typed languages, all things being equal, which they never are, but it's a preference.
Mm-hmm.
And I think that leaning has become more pronounced in the age of these machines that love automatic verification, that love the instant feedback. Are you feeling any sort of lean towards certain languages for the age of AI coding? Do you think there are certain ones that fit really well?
It's a really interesting kind of area at the moment. And obviously, it's true to say that the Python, TypeScript are becoming the languages of AI development. They're the kind of default if you're running your LLMs somewhat on default mode. Those are the languages that you're going to tend to get, and so we're just going to see this virtuous
if you don't
feedback
care,
loop.
the LLMs will tend to recommend those ones, right?
Yes, that's right.
Self-reinforcing.
And it's not the only consideration, of course, and both you and I have a background in Clojure, for example, and with a Clojure MCP, with something that links an LLM up to a REPL where it can evaluate the code that it's generating in real time. Clojure is a very terse language, and therefore it's very token efficient. And so there's an argument to say that just because Python and TypeScript, the default languages of LLM development, necessarily means that they've won, and those are the only languages that we should be using.
Yeah. I definitely think there was a very brief phase where LLMs performed significantly better on the popular languages. I don't think it lasted that long.
No.
I mean, I've been using a bit of Gleam recently, which is a very obscure language in the grand scheme of things. But I wrote a skill for it. I got it to download the tutorials and create some notes from that. And it writes Gleam as well as it writes TypeScript, as far as I can tell.
One of the things I'd like to talk about today is the behavioral specification language that we've built in JUXT, and that's a brand new language that LLMs have never seen before. That's described entirely by a skill. It's a skill that describes the rules of the syntax of this language, and it works really well. It benefits from having a command line checker, which can symbolically check that the syntax is well formed, because often it's not perfect, but it's certainly good enough. So it's phenomenal. The current wave of LLMs, particularly Opus 4.6, really strong. And I think any argument about what's well represented in the training data, those kind of arguments haven't aged so well.
Yeah. It's funny how you can have an argument in the AI world that probably has a 2-month shelf life.
Yes, that's right.
Which is, and we are going to get into your specification language. We've got so much to get through. Speaking of shelf lives, though, you, as part of JUXT, have released a kind of AI radar. What's hot and what's not in AI, which gives us a whole bevy of techniques and tools to talk about. But the first thing we have to say is, to release a radar, you have to put a footprint in the sand and say, these things are important right now, those things aren't. And almost as soon as you publish that PDF, it's aging very fast. How do you give any advice that's going to last long enough for the effort of creating a PDF and publishing it?
Well, it's a quarterly radar for a start. I think when we first published it, there were some voices saying, "Should we make this annual?" I mean, and yeah, the half-life of the advice in it is probably 6 months or so. Very hard to say, but yeah, it's an ambitious task. And thankfully, we've got AI to assist with research and distilling our thoughts and the things that we're observing on client site. We're a relatively small team producing it, and in a pre-AI world, it probably wouldn't have been feasible to do so. But it really does exist. It's on our website, but also
look,
it's
an
a
actual
downloadable
printed
PDF
copy.
and a real printed copy. Yeah, it's
Actual tree. Brilliant.
The latest version is 60 pages. I think we've got almost 70 blips. Last quarter, we added, I think, about 15 or so. As I say, the pace of change is dizzying.
Yeah, and keeping up with what's worth paying attention to and what's still going to be worth paying attention to 3 months from now is really hard, which is why I was drawn to this. It's like, well, at least someone's trying to pin a few things down.
Yes,
and
that's
expose
right.
some new ideas.
We enter it in the spirit of sharing what we currently think to be true, but accepting that as the industry evolves, we will inevitably, new techniques will come in and displace the old, but we'll simply report those things as we observe them. And I hope there's some use in that.
Okay, let me pin you down on one specific one, which already I think is aging pretty quickly. I heard something saying yesterday, MCP is dead and skills are the new hotness, essentially. And I don't think that's what you've got on your radar, as it was published a few weeks ago.
End of January. So
end of January, so 2 months already. What's your take on MCPs? Is MCP dead? Are skills the new hotness? When would you use which one?
So MCPs, right? Just for those who might not know, you think of them as a bit like a sort of USB interface between an LLM and the outside world. They're a kind of generic connector that allows you to plug into all kinds of systems, Confluence and Jira and all that kind of stuff, but also the web, databases, you name it. If it's got an API, you could write an MCP to interact with that API. A skill, which is a more recent invention, I think it's 6 months or so ago that skills became a thing. It's really just a markdown file or a set of markdown files describing an approach that you want the LLM to take. It's condensing some kind of knowledge or process or point of view. And it's like, I suppose, an extended prompt that you can just pull into your context on demand. And it's true. I mean, you could have a skill that communicates how to use a much more generic interface, like the command line or HTTP, to use an API rather than having a bespoke MCP specifically for that API. So there's definitely a sense in which skills can displace some of what MCPs were used for. But there is one thing that the MCP server provides that skills don't, which is that they're an external process. Often they're written in something like Node, so they can hold some persistent state. If you're talking to a database, they can hold that database connection, and they can be, rather than if you're using a skill where your context window has to contain the skill itself, then of course your multiple turns of what you say, what the LLM says back to you, this all fills up context. MCPs can use that context more effectively. You don't have to pollute your global context with kind of traffic going on with the MCP. So there's a judgment call, as with all these things, where it might be that you benefit from a generic MCP and a bunch of specific skills, or not. Your mileage may vary.
We're still figuring out what the sweet spots are, possibly.
Exactly. I mean, as with all these things, like at what level of abstraction is the right one? Are we going to have a few very generic kind of MCPs rather than, as I think, people got very enthusiastic a year or so ago when MCPs came in, and suddenly there were tens of thousands of them. I think we've started, initial enthusiasm has ebbed slightly, and we're realizing maybe, one MCP for every single API in the world is probably not necessary.
Yeah. There is one I discovered last week, which I like, and gave me a thought about this, which is the Jira MCP server. Firstly, great, because sorry if anyone loves Jira, but I was glad to realize I wouldn't have to touch Jira in order to use it. But also, I realized, like MCP, I will never have to be responsible for maintaining a Jira skill, because the burden of updates is on the MCP provider, and that seemed quite useful.
That's true, isn't it?
You don't need to keep your skill and command line tool in sync.
There's an inverse to that, and I'm sure I've seen you, Chris, say things like, I had this idea, but I'm not going to turn it into a project because now you've got the idea and you can make it happen for yourself.
Yeah, I wrote an MCP server for Kafka, and it took me 20 minutes, and I realized, well, what's the point of maintaining something that takes 20 minutes to reproduce?
And if it takes 5 minutes to update, maybe that ongoing maintenance burden is not so so much of a concern.
Do you find that with client work, that they're building in-house more because it's easier?
Well, that's definitely one of the things that clients are thinking about right now is, if we're seeing that a single engineer or a group of 3 engineers can make a whole SaaS tool in a week, why do we need to pay vendors several months to achieve the same outcome? Of course, it's there's a lot of noise and turbulence in the industry right now as people are trying to figure out how this is going to work. It's one of the reasons that at JUXT, we are really keen to be embracing these tools and using them to their absolute best effect. We're operating as much as we can on the frontier so that our pitch can be, it's true, AI is a massive accelerator, and that works in both directions. We know how to use them to achieve the goals that we need and to exercise that good judgment about making sure that we are not vibe coding into production. We're building high quality code, but very fast, using everything that we know about how to constrain the behavior of LLMs productively. Your internal teams might be exploring these things for the first time, and there's a lot to learn. And an accelerator doesn't steer. It could accelerate you into a wall. And so I think what we will start to see over the next 6 months to a year or so is a bunch of organizations realizing there's actually quite a high there's a steep learning curve associated to using these things well, and so I'm betting that there will continue to be a place for consultancies like JUXT.
Right. You give me the impression, because there's a lot of headlines about companies adopting AI and the speed and the enthusiasm coming from management. You give me the impression that the companies you're talking to are more in an assess mind space than diving straight in. Is that fair? Is that because you tend to work with banks or insurance type companies?
It's interesting. So banks and capital markets organizations, those in financial services, are obviously constrained a great deal by compliance, and so they are risk averse. They are also massive development shops with tens of thousands of engineers, and so the risks are clear and present, but the rewards are massive too. And so we're actually seeing quite substantial uptake. And the reason we're seeing it, of course, is that the we're involved in these transformations, and we're building the AI platforms that tier one banks are using to exercise safe interactions with LLMs. So, for example, checking that they're not inadvertently leaking PII, defending as best we can against things like prompt injection. So, I think that although I think the assessing comes in figuring out how internal teams can start to leverage AI in a safe way, and how to navigate the costs. If you've got tens of thousands of engineers, you don't suddenly want to give. I mean, well, for lots of reasons, you don't suddenly want to give them all access to the latest and greatest models. So, figuring out that kind of thing is I think what's being assessed right now. But there is definitely a lot of ambition for realizing the benefits of AI. And luckily, we're in a position where we're helping to build those platforms that make that happen.
Yeah. Okay. Then I wanted to get onto platforms, so let's go there because, like, there are things like Claude, Codex, Cursor, Cortex is one that the company I'm working for is currently released. Right. There are these individual programmer accelerator tools, and then there are these larger, more coordinating pieces. I'm thinking of LangChain, but I'm also thinking of like Gastown.
Yeah.
Give me your read on the larger orchestration picture.
Okay, so I mean, so some of the trade-offs to think through are the amount of runtime flexibility you're going to give to your agents.
Right.
I'm thinking here, like if you've got some kind of production system you've stood up, do you want to have provided tram lines for everything, have thought through exactly what the workflow needs to be, and something like LangChain, LangGraph will specify the full workflow very precisely, and that is time consuming, but of course carries enormous benefit that you've got a lot more confidence that you know what's going to be happening when you hit go. When you submit some kind of request into the public API. Something like Gastown, all bets are off. The process is expressed through this kind of mad management hierarchy, and Steve Yegi's great fun. Like he's an excellent writer. His blog posts are a good read, and he's invented this. It's a slightly Heath Robinson contraption, and I think he would agree. And all credit to
I
him
feel
for
I have to
taking
say, for the American market, Heath Robinson is our version of Rube
Rube
Goldberg.
Goldberg. Yes,
It's like an
yes,
elaborate, overly complex machine.
yes,
Yeah. Sorry, go on.
absolutely. And uh, he's very open about the fact he's vibe coding this thing, and he's reaching into kind of popular culture for the names of his various components. And I'm not sure that Gastown is the solution to what this kind of open-ended orchestration framework is going to
For those
be.
that haven't dived into it, can you break down what it actually is and then what you do differently?
Well,
I'll
so
bring the
first of
easy
all,
question.
yeah. Well, so what it is, it's a multi-layer agent orchestration framework, which is aiming to give you as the user access to a small army of workers. And your entry point is to talk to something he calls the mayor. And you talk to the mayor about what it is that you're trying to achieve. And then the mayor is going to delegate to a whole bunch of sub-agents who in turn are going to delegate to sub-agents themselves. And because agents are kind of trained to be, at least currently, helpful assistants,
Hmm.
they often sit there waiting for user input. They'll sort of ask a question and then stop. And so a lot of the effort in Gastown goes into prodding these helpful assistants and trying to sort of turn them into huskies pulling your sled along. So they're just going to be focused on a goal and keep iterating to get there. So there's I think there's a deacon is one of the agents, which is pinging dogs and polecats, and I get a bit lost in the details, to be quite honest with you. But the objective fundamentally is just to keep the machine running, and it's a slightly unwieldy beast because you're fighting against these LLMs' kind of innate preference to kind of do some work and then come back to you. What would I do differently? Oh boy! I mean, so the way that I prefer to work, I think multiple agents running in parallel is enormously powerful. I am a little bit uneasy about simply submitting short requests to a mayor and then trusting the code to be written, tested, merged, and delivered without any involvement from me. I'm not quite there yet, personally.
Right.
What I prefer to do is spend some time working on what a solution should look like, which oftentimes is involving me developing my own understanding and helping to reason through what my requirements actually are. I don't necessarily know ahead of time, and using AI to scaffold my own understanding through a kind of Socratic process, coming up with something that's a well-defined specification, not for the whole system, because I don't want us to return to waterfall, where we're trying to design everything up front, but a specification that is a clear description of my intent for some component. And then we can fan out to multiple agents in parallel. And there, Claude Code's agent teams, which is only about a month or 6 weeks old at this point, I think it's still in kind of preview, is really useful. And I find that a very robust way of having these kind of long horizon pieces of work where you might have quite a substantial specification. It might take hours for agents to correctly implement and test everything that you've asked for, but you can probably decompose that problem into a few parallel units of work. You've got multiple agents to do that for you. That's my preferred way of working. It's much more kind of involved in the process, and then I've got a choice about, do I go away and do something else for a bit, or do I stay looking over their shoulder, and perhaps I'm off, doing something else on my machine, but keeping an eye on what's going on. At the moment, I like to do that where I can, because it allows you to see whether actually, in spite of your best intentions, there was a misunderstanding or misapprehension, and you're starting to see files being touched that you didn't anticipate, and so on, and then you can jump in, course correct.
Yeah. I don't know if I will agree with myself 6 months from now, but at the moment, I find I want to be fairly hands-on with architecture. I'm really quite hands-off with code. And do you think there's a sweet spot for how involved you get? And do you think it's going to stay that way, or it's got like 2 months before the sweet spot moves again?
Well, yeah. So we talked about code distance earlier. Design distance, I guess, is another spectrum, and I'm with you. I prefer to have very small design distance. I want to know how the system is constructed, and I think that's still the place for good engineering judgment, is in good architecture, good design. I think we've seen a bunch of examples recently where, for example, the cursor fast render experiment, where they had thousands of agents working for a week on building a browser by reverse engineering the specification.
Oh, I didn't see that one.
It was a complete shambles. Like, there was no central organizing force. You had a bunch of, as I say, thousands of agents off doing their own thing with as far as I can see, almost no coordination. And and the results are somewhat predictable. That there were multiple independent implementations of certain key components, and I think some small proportion of the builds actually compiled, and I think that's a sort of illustration of the risks where you don't have a clear design. The velocity doesn't really mean anything if what you're building is this sort of fractured and entangled mess. And there's a kind of Conway's law analogy. We've often known with human teams how they tend to build software in their own image. And if you've got one team doing something and one team doing something else, that's going to end up being reflected in the architecture of whatever system they collaborate on, and their team boundaries will become service boundaries and API boundaries. It's one of those things about how design works in groups. And LLMs are kind of subject to the same thing. If you don't constrain them with some kind of overarching design, they are polysemantic, fractured and entangled machines that tend to produce code along those same lines.
Yeah, I can see that actually being much worse than the classic Conway's law examples. Because what was it he said? Something like, if you have two teams, you'll end up with a two-pass compiler. But with LLMs, you could easily end up with 1,000 agents, which is 1,000 teams if you do it wrong. And then
exactly.
Yes. Okay, so this makes me think of pinning these things down a bit more, and there are various techniques for this. Going to get onto your big one, I promise, but there's a particularly spicy term in your radar that relates to this, which is neurosymbolic AI.
Mm-hmm.
What on earth is that?
It's a fun one, isn't it?
Yeah.
So, although contemporary frontier LLMs are extremely powerful, and they're called reasoning models, and as we've said, it's kind of pseudo reasoning, but boy, does it get you a long way. But the researchers analyzing these models show that, for example, there was that Apple paper from, I don't know, 6-9 months ago or something, that was getting various different kinds of LLMs to solve problems like the Tower of Hanoi type problem. And it showed that there was a sweet spot for reasoning models, which was sort of moderate complexity. But in a kind of mad counterintuitive way, reasoning models actually performed worse than the non-reasoning models on really simple problems, because they kind of overthink themselves into a bad solution. And so, it's no silver bullet. And when people like Anthropic look at what's going on inside these models, really interesting research. It's the kind of research that shows that they're polysemantic and that neurons represent multiple concepts, and you've got to look at clusters of neurons in the LLM in order to understand what the LLM is thinking. And what was it, about 18 months or so ago, Anthropic built Golden Gate Claude, where they kind of proved that they'd identified the cluster of neurons that represented the Golden Gate Bridge, and they were able to dial those up so that basically every question you asked of Claude, it would find a way to reference the Golden Gate Bridge. So if you asked it, how you should spend $20, it would advise paying the Golden Gate Bridge toll, and that kind of thing. So we can interact with these models, but they're not doing symbolic reasoning. They're doing kind of vibes-based pattern matching. They're kind of metaphor machines. They're looking at things that are like something else. Of course, this
we might be too, though. That's not necessarily.
Well, we've got kind of two modes, haven't we? We've got the kind of system 1 and system 2 type thinking, and the analogy is that the LLMs are this kind of fast, intuitive kind of way of thinking, even when you're forcing them to reason. And it's really cool that it works. But there's this there's something that researchers spot called motivated reasoning, where if you kind of ask Claude, or indeed any reasoning model, a maths question, but you imply that the answer is something that it's not, you're often going to get the model, finding a way to make you right. And it'll say, oh, yes, the answer is that, and this is how you get to it. And it'll construct some kind of plausible chain of thought to get there. But it's just not true. This is a problem that LLMs have, and it's a sort of fundamental architectural limitation. But you can pair them with some kind of symbolic reasoning, which is doing proper consequence analysis. It's maybe something like Prolog that's solving a well-formed problem and providing you with exactly the steps to get there. You know that it's correct.
Take me through how that would work, because the return of Prolog to the conversation is not something I could have possibly predicted.
Well, isn't life funny? And it doesn't have to be Prolog, of course. It could be giving access to a calculator, for example.
Right,
give the LLM a tool that does execute symbolic reasoning in a way that LLMs will try, but potentially fail to do. And then a combination of the two can give you much more confidence that you're going to get good results. And it opens up the possibility for applications in places like regulated environments where you need to show exactly the steps that were taken, but perhaps you want to have some kind of fuzziness to your inputs, maybe plugging Prolog directly into whatever upstream systems you have isn't viable. But you can use the LLMs for what they're good for there, which is translation. And then ensure that the steps that need to be correct are indeed correct.
Are you saying that we're gonna? I'm trying to picture this. Are you saying that we're going to get? We're going to write some kind of Prolog model of the system, and then get the LLM to say, "Here are my facts. Are my conclusions correct?"
Well, it might not be checking. It might not even be attempting to come up with its own conclusions. You can, in creating a hybrid neurosymbolic system, the idea is, and of course LLMs can write code. So this is another thing. It doesn't necessarily need to be that you've written your system in Prolog. And again, it doesn't have to be Prolog. I just think it's really funny that this language from the 70s is suddenly finding a potential application. Again, still very early days. But it could write Python, for example. And so you can have your LLM writing some code that can then provide an answer with a kind of audit trail for how it got there, and then take that answer and run with it. So yeah, it's just this idea of a hybrid with each part providing what it's good at.
Maybe I'm getting confused. Are we saying like it will write programs to assist it in the act of writing programs, or is it more like when you ask it a non-programming question, it might lean on a programming language to do some of the rigorous parts?
Exactly that. Yes.
Right.
That's right. So, it's tempting to try and use an LLM as the solution to every problem, and bless them, they will try. It's rare, but you start to see it these days, and I guess there's a lot of work going on in the post-training to guide LLMs to be transparent about when they can't answer a problem. And I've only had it a handful of times, but I might get a response that says, actually, I can't help with that. Which is useful. It's better than the alternative where you get some kind of motivated reasoning or a hallucination or a confabulation and don't realize it. But better still would be if the LLM goes, well, I can't do that because I am, a semantic next token predictor machine. But what I can do is write a little helper function that's going to provide the right answer for you. So I'll go away and do that.
Right. Is there a particular field that's being applied to, or is this all just experimental?
It's still really early. It's a sort of emerging architecture. But it's a very general principle. So although I can't think of a particular field where this is becoming prominent, anywhere where you've got this mix of requirements and you need some kind of auditability, you want to bring some kind of symbolic reasoning into play, it's another tool in the toolbox, and that'd be really interesting over the next year to see whether this takes off, or whether we find ever more ingenious ways to juice the ability of LLMs to the extent that people get away without it.
Yeah. I have been feeling recently that even if the sophistication of LLMs themselves plateaus right now, there's still an enormous amount to be discovered in the way we use them and the way we orchestrate them with other tools.
That's right.
This is actually one reason why I invited you particularly to talk about this topic, because as well as like using off the shelf LLMs, as many of us are, you've done lots of training of your own models in the past. And I want to get your read on to what degree is it now worth training a specialized model from scratch, taking an existing model and tweaking it, like post-training new weights? To what degree do we distill large models into small models? Is there space for all these techniques? Because it seems like, apart from cost of tokens, you might as well just throw a large model at everything and be done with it.
There's a lot of truth to that. Trying to compete with the speed of development of the frontier model providers is almost certainly a losing game. So you need to have quite a high threshold, I think, now before you decide to do your own model. But as you say, this has been something that I've done in the past, and where it is still useful, I think, is if you've got a lot of so one of the use cases, for example, is classification, and a prior role, I worked for RegTech, and what we needed to do was classify regulatory text, and there's a rich and storied history about text classification, and we reached for some of the really good classical ML techniques early on, things like support vector machines for classifying regulatory text. This was around the time that LLMs were coming to the fore, and so we just decided to see how well an LLM might perform, and it outperformed the classifier, as long as we fine-tuned the LLM on our training data and provided it with the hundreds of thousands of training examples that we collected over years that gave it a kind of intuitive understanding about how legal text related to the classes that we wanted to apply.
Right.
And so that fine-tuning provided this sort of, intuition is probably the best word, actually. It meant that we didn't have to have massively long prompts that described exactly how you should classify each piece of legal text. It had learned by example.
Right.
If we had tried to put all of that into a prompt, we'd start to hit the kind of lost in the middle type challenges that happen when you've got very long prompts, and LLMs tend to be much more sensitive to what's at the beginning or end of the prompt and forget what's in between. Or we'd sort of hit context window limitations and that kind of thing. So there's still a place, if you've got this kind of repository of your own information, valuable business knowledge, that you want to give the LLM a kind of intuitive knowledge about. Fine-tuning still has a place. It's more common, though, that you plug them into some kind of RAG pipeline, and if what you're actually doing is information retrieval rather than classification or some other kind of machine learning-y thing, if what you're asking for is fetch me the relevant information, you don't really have to fine-tune a model. You can vectorize your data. You provide a means of looking up, based on a query, the potentially relevant data. Then you can provide that to an LLM, and you're unlikely, if as long as you're not finding hundreds or thousands of responses, you're not going to exceed the context window of an LLM to be able to sift through that and come up with a good response for you.
So modulo cost, you really are leaning towards just frontier models with the right techniques and orchestration around them.
Yes, for most people, there's a maintenance burden. As I say, trying to keep up with frontier models is probably a losing game right now. But also, you need a bunch of embedded expertise in your team in order to do things like fine tuning well. You need to be hosting your own models. So that carries a cost and an overhead that's not insignificant.
Fair enough. That reminds me of something I was going to ask you. Hosting your own models, as a company, that's a big ask, right? You probably want plenty of servers with 300 gigabytes of video RAM or whatever. But there's also the hosting your own locally, which, what's your experience here? Because my experience is it's impressive how much LLM I can run on my 32 gig MacBook, but it's still kind of brain dead to what I would get if I go for the cloud. Is that your current experience, and do you think that's likely to change anytime soon?
Well, that is indeed a probably billion-dollar question.
Yeah, many large companies' fortunes are riding on it being a no. You'll always need the cloud.
Yeah, exactly. And my hunch is that the opportunity of being able to run something locally on commodity hardware is too great for us not to find a workable solution in the next year or two. And yet, at the moment, you're right. We're kind of spoiled when we can go to the cloud and get this really sort of emotionally intelligent AI kind of coming back to us with questions that we didn't even think to ask. And then you go to a local version, and it's much more sort of pedestrian and slower. And so that introduces kind of friction, and it means that most of us aren't doing that right now. But just imagine if we find a way to make these models much more efficient and provide, for at least for certain domains, enough capability that you don't feel that kind of friction anymore. Of course, that's what we would want to do. Our data stays local. We don't have to worry about inadvertently leaking it. Costs are much more predictable. At the moment, if you really want to do it, you do need a lot of RAM, more than 32 gigs. I mean, even more than 128 gigs, really, which is what I've got. Ideally, you'd have 500 gigs would be great. You could run Kimi locally, and you get a pretty comparable experience to running Claude Opus. But that's going to be outside of most people's budgets right now.
Yeah, and sourcing availability.
Oh, indeed, yes.
It's hard to get hold of memory at the moment.
yeah. But anyway, there is something I'm following with very close interest right now, and I'm sure it will make its way into the next radar. I think it's a Finnish company called Talas, which has built a chip which has the weights of, I think it's one of Meta's models, one of the Llama models, encoded in it. So it's a sort of LLM as a piece of hardware, and reportedly, I think it's 17,000 tokens a second. So it's basically instant.
Wow.
And so
the current numbers are something like what, 20 to 50-ish?
Yes, depending.
17,000.
It's not inconceivable for some those with enough budget. You could have Claude on a dongle, before too long. So maybe that's another solution.
Yeah, they're going to really struggle to keep them up to date. But again, maybe that won't matter. Maybe if the LLM power plateaus and it becomes about orchestration, then you find that really what you want is enough USB ports to plug in all your Claudes on a dongle, right? I've only got 3, and one of them's being used to attach my camera, so that's no good. Okay, let's go back to production then, and stop speculating. The other topic I really wanted to talk about, which is very much at the coalface, is LLM observability.
Mm.
Like, we know it goes well, we know it goes badly, and I know you've put on the radar like tools for keeping an eye on them. Is this like monitoring pipelines into production, or auditing
Yes.
whether your whether your developers are using it right, or what's the state of the art there?
So, yes, I mean, it used to be that we were much more concerned about training our models and evaluating them during development, and then you'd push them to production and they just kind of worked. And if you were very diligent, you might be looking for data drift and things like that over time, where you'd be checking that the distributions that you were training on were still correct in production. Now, of course, if you've got sort of agent orchestration going on, you need to be paying very close attention to what your system is doing. You need to be knowing, keeping an eye on kind of tool use that agents are doing, how they're talking to each other, whether they're stalling, crashing, and so there's a whole emerging set of tools which will provide you that kind of observability. And I mean, Phoenix is quite a good one. It's very easy to get started with.
Okay.
You get to see traces. You get to see what's going on, and provide nice metrics and graphs and so on that you can start to see if something is not going how you anticipated. And it's kind of paired with workflow tools as well, like Temporal, for example. So because if you're talking to the SaaS model providers at scale, you're going to start to become really aware of some of the stability issues that they are struggling with as the world tries to use their API. And so getting really robust around when the service is unavailable, back off and retry. If your agent crashes in the middle of a long multi-step workflow, you don't want to start back at the beginning. You want to pick up where you left off. And so Temporal's in our radar as well for that reason. It provides the ability to kind of, it's like a save game in your workflow.
How does that work? What is Temporal in detail?
So if you think about Kubernetes, which is orchestrating machines, Temporal is orchestrating your agent workflows. And so it's providing a way of keeping durable state in a way where if your machines crash, if your agents crash, things will always be able to pick up where they left off. And some of these things are very long running. And so it might be that human approval steps are part of your workflow, in which case, perhaps there are days where something is sitting in a particular state waiting for some new thing to happen. Temporal provides a framework for specifying that behavior in your own programming language. I think there's Python, Java, TypeScript, and so on. And so, it's a nice way, quite good ergonomics of writing these robust workflows.
Is that fundamentally as simple as persisting all the context windows from the various agents? Because the nice thing about an agent
make it sound so simple.
I do, and I'm trying to get, and I'm not trying to dismiss what they're doing. I'm just trying to get to the hub of the architecture. Like, the nice thing about an agent is fundamentally it has state, but its state is just a big long text transcript, right?
Mm-hmm. Well, yeah, from the outside, I think there's all kinds of mad science going on for efficiency. But yes, from the outside, that's right. Big long context string.
Okay, so managing those at scale and doing a simple task at scale is always harder than it sounds.
Yes, that's right. You've got these essentially an arbitrary number of long-running processes that you want to pick up based on triggers in your workflow, other events and things.
And just for my local version of that, because I often find I have like companies have orchestration problems. We're finding developers have orchestration problems where I've got 3 or 4 instances of Claude code running and I'm just waiting for the next one to ask for the prompt, right?
Mm-hmm. Yeah,
I
we're all
imagine
moving
this.
into management, aren't we? We
Yeah.
thought we were ICs, but it turns out now we're responsible for a team. And the
Team of
analogy I quite
robots.
like is that we're going from being kind of pilots to air traffic controllers, a completely different way of working.
Yeah, I can see that. That's quite a good way of thinking about it, and sounds more glamorous than going from contributors to engineering managers,
Yes,
doesn't it?
that's right.
I imagine air traffic controllers would say it's not that glamorous, but are there good local? I mean, would you use Temporal or Phoenix locally, or are there local management things you would recommend instead?
That's a really interesting question. I mean, so as I say, my preferred workflow is basically an agent team and fanning out and then back together again. It's what would be the circumstances in which I've got a genuinely long running process? At the moment, I think probably 4-6 hours is probably the longest I've ever left agents running unattended, and that will have required quite a lot of setup to make sure that I've got some idea of what's actually supposed to be happening then. So a lot of upfront specification, and then a Ralph loop. I suppose that's the dumb answer.
The Ralph
where if
loop.
you've got some hairy, audacious goal, for example, you've spent, as I have, a day with an AI iterating in a lot of detail on the specification for a full distributed system spread across 10 files. It's like 3,000 lines of specification, dense, code-like specification, not human prose.
Okay.
Then you're asking a lot of even an agent team of LLMs to go away and implement that. That's going to be a lot of code. And there's this, quite sort of, it's annoying, but a quite sort of fun, whimsical quality of LLMs of being like a sort of a genie that will often find a creative way of telling you that they've done what you asked, but it was never quite what you intended. It's maybe it's the letter rather than the spirit of your request.
Yeah. The classic one is I've got the tests working by disabling all the tests.
Exactly. But a Ralph Wiggum loop is a very simple way of combating that, which is to, if your prompt is something like, I've got a load of specifications sitting in the specs directory, read them and implement the code that they describe. You give that to an LLM and it will go off and it might run for several hours and it will come back and say, yep, I've done that. And on closer inspection, you'll find that, maybe it went really deep on a particular component, and that is great. That's been implemented, but there's whole other areas that have just been completely ignored, or maybe it will have taken a very broad brush approach and implemented everything a bit, but missed lots of the detail. But the kind of the genius insight is that you could submit exactly the same prompt again and say, take a look at the specs directory, implement the system that they describe. And when the new LLM wakes up with a fresh session, it's brand new contributor, it will take a look at the code you've already got and say, oh, that's not quite right. This doesn't match what the user has asked for. So I'll go away and I'll start on that. And that next LLM will take you a bit closer. And of course, you can just loop as many times as you need to. And this maybe is where the new engineering judgment comes in, is knowing how to specify that prompt, how many times to iterate, how much upfront work to do. It will get you eventually, after some number of goes, perhaps towards broadly what you wanted. And this has been my experience, even with very sophisticated distributed systems, that you do eventually get what you want. So
you've tried this with something meaty and it actually works?
It does work. Yes. Yeah, absolutely. I've written about it. So distributed, strongly consistent, very high performance system with Byzantine-fault tolerance. It took a weekend of elapsed time and probably about 20 hours of LLM time to implement, but it works. And of course, the fact that you can, if you specify the intent that you have for your system, but not the implementation, you give Claude or your LLM of choice a lot of latitude to solve the problem, but whilst being constrained by your invariants, the things that you that must be true, like the fact it needs to be fault tolerant and the kind of error conditions that we need to defend against. And I had the experience of Claude realizing that there were bugs that only happened under certain crash scenarios, and repeatedly setting things up, killing them, and looking to see what happened, and then maybe adding instrumentation, little bits of code that would be logging, doing things again, in a way that I would have been very, it could be quite tedious drudge work to do that. You're sort of trying to reason through complex race conditions in a distributed system. But if you've given the LLM enough context about the goal, and it's a goal that can be verified, then my experience has been they're a fantastic tool for just patiently, diligently working their way through a solution. The same is true for latency. I set a really ambitious latency goal of our P99 latency being under 100 milliseconds at 10,000 requests a second. And again, it had access to the load test rig. It obviously had access to the code. And our first attempt, our P99 latency was 30 seconds. I think it was 31 seconds, in fact. And then over the course of some hours, we got it down to something like 25 milliseconds. And part of that was Claude realizing at some point that it had noticed that the P99 was stuck on 208 milliseconds for ages. In spite of what it did to the code, nothing seems to shift that persistent tail latency. It added some instrumentation to the code, separate from our load test rig, that confirmed that actually nearly all the requests were happening under 100 milliseconds, and realized that the latency was being introduced by our Docker networking bridge, and decided all on its own, okay, I'm going to move the load test rig inside Docker. And then suddenly, the latency dropped. And that was all completely hands-off. I just said the overarching goal that I wanted to achieve and left it.
I mean, that's insane for building large systems. I have to ask, before I completely react to that, how much do you now trust that system that's been built?
Well, I have a lot of tests. It is better tested than most systems that I've been involved in. And I think that's the fascinating thing about AI-assisted engineering, is it's we always knew that comprehensive testing of at least the important critical parts is important. And yet we were always constrained by what we could reasonably achieve in the time that we had available. The calculus has shifted with AI, and suddenly it's feasible to implement tests for every conceivable scenario that you think you want to defend against. Or that's quite sort of reactive. Maybe you're writing tests about code that already exists. You could spend the equivalent amount of time making sure that you absolutely understand how the system should behave in all kinds of adversarial scenarios, and make sure that behavior is really well specified in a way that theoretically you could have done before, but maybe you'd have been working on a whiteboard and that's got kind of finite space, and then somebody comes along and rubs a bit out. Whereas now you're working with an LLM on a behavioral specification file that's durable. you can be interacting conversationally, and so you can be asking questions of like, what happens if kind of thing that previously might have been quite hard to reason about, but now you've got the LLM there for signposting and assistance that mean you can be much more rigorous. And so in a funny sort of way, we're all, I think, not unreasonably, we've been worried about vibe coding and the spaghettification of code with LLMs, but in diligent hands, you've now got the opportunity to do the things that we always should have been doing much more rigorously. And perhaps we're going to see certain types of software that have been built along those sorts of lines being much more resilient than they ever were before.
Yeah, I can see that. I genuinely can, with the extra capacity and diligence. I have to ask you the halting problem. How did you know when to stop looping?
Well, at some point, you're going to get a few consecutive responses that say, "Yep, there's nothing more to do. Everything looks fine to me." Eventually, yes. I mean, it might take some very long number of loops, and I wouldn't ever trust the first one. But once you've done that a couple of times, probabilistically, on the balance of likelihood, you go, "Okay, I think we're there."
Okay. Then I have to ask you, for building a system of this kind of size, you talk about pinning down the specification and the constraints. That leads me to your contribution to this field, which you've been working on a system for pinning down constraints for the sake of LLMs, right? And for the sake of agents. Tell me about that. What's your novel addition to the world?
So it's called Allium. It's a language for behavioral specification. It's an LLM native language.
What does that mean?
It means that there's no runtime except for the LLM. There's no compiler except for the LLM. It exists as a specification of what the language is, and it has an accompanying skill which teaches your LLM how to read and write files in this format. And the language guidance provides a lot of information about how a behavioral specification should be elicited from a stakeholder. There's also another mode that you can run in where it looks at an existing code base and distills that code into a behavioral specification. So it looks at the how of the code that actually exists and then attempts to reason about the what it was trying to achieve and to encode that as a behavioral spec. And the thesis behind this is that we're seeing a rise in spec-driven development. You've got things like SpecKit and Kiro and Claude Plan Mode, and generally the solution is markdown files. Going to write a long human prose description of what we're trying to achieve. There's definitely value in that. It's certainly better than nothing at all. But human language just naturally hides contradictions, and there may be ambiguities there. That in a long specification, a person might miss the fact that you're a bit ambiguous around the kind of authentication model that your system needs to have, or whether guests are allowed to do certain things, or what the. It's not just about security, of course. It's also about any aspect of the behavior of your system. And so the thesis is that providing a formal way of expressing your behavioral intent provides much less opportunity for that to happen, because you can start to leverage the LLM's ability to spot bugs in code if you're expressing your behavioral intent a bit like code.
Right. Give me a concrete example. What does it look like when I write some Allium?
So it's not designed to be written by humans. It can be read by them, because it's designed to look a bit Python-y, TypeScript-y. So in fact, we are trying to leverage that point around well represented in the training data, just to give the LLM a leg up. Given that we're teaching it about a brand new language, it's literally never seen before. but it arises through conversation. And so you would start by saying something like, I want to create an Allium specification for my system. I want it to do X, Y, and Z. And the skill around the specification language will be the one that teaches the LLM to say, interesting. When you said customer, what did you mean by that? Do customers map to accounts? What can they do? And through this kind of conversational iterative process, a lot like a product owner might have with a senior engineer, or so on, you get this rich and quite rigorous specification of what the system needs to be, completely independent of implementation. It's got nothing to say about the database that you're using or the web server that you're using. It's pure behavior. And so this is how we can kind of avoid getting tangled up in implementation concerns. And it's really powerful because LLMs kind of snap to the code. If all you've got is the code to look at, that is both the description of how the system should work and what it's trying to do, condensed into the same kind of substrate. And yet there's no reason those two things have to be expressed in exactly the same way, because the how has all kinds of other things to grapple with, sort of implementation constraints, libraries, and maybe there are kind of expedient workarounds or bugs lurking in the code. Having a completely separate way of specifying what the system should do isn't duplication. To my mind, it's providing the kind of resilience that you get from also having tests, which are expressing what the code should do in a different way. The trouble is that because LLMs tend to update both the code and the tests at the same time, they're both kind of evolving simultaneously. You've got no fixed point around which to check that those changes are correct. Whereas if you've got a behavioral specification as well, then if you're only ever changing two of those at once, you've got that kind of fixed point. It's a bit like three legs of a stool.
Right. So are you saying the workflow here is I have a chat with my agent to produce Allium files as an asset, which are then fixed, and you would then go on to have it implement those, but you'd expect to get a change which changes a lot of source code files but doesn't change the spec files?
Exactly. You will tend to be changing one or the other at any given time. And you can do as much upfront specification as you want to do. Part of the reason for wanting to build this language is to work, to have it built entirely for that way of working with LLMs, where you want to start by speccing out a prototype. But you want to put that prototype under some kind of behavioral specification, because then that allows you more easily to sort of grow it in a kind of rigorous way, where you're not going to end up in the situation where you try and change one bit of the code and another bit breaks, and then you try and fix that bit and the first bit goes back to how it was, because it can be a bit like playing whack-a-mole sometimes. So it's designed for this kind of iterative way of working. You start with a conversation, as I say, unless you've got code that you want to distill into a specification already. And you do as much as you need to. And the specification has provisions for open questions and deferred specifications and other bits which are explicitly acknowledged to be kind of open at that point in time. And so when the LLM, a different LLM probably, is coming along to actually implement that behavior, it can see, this bit is the bit that has been well specified. This is the bit I will write good code for, and that bit is currently undefined, so I won't do that. And so, it's when you hear spec-driven development, often people think, we're back to big design up front and waterfall thinking. That's exactly not the approach that I advocate for. This is definitely an incremental and iterative process. It's just providing you with that fixed point that means that you've always got some stability in your iterations with your LLM that allow you to keep walking forwards rather than get caught in some kind of doom loop, which is probably an experience that lots of us have had with LLMs, where we reach a wall and there's a massive drop off in our velocity. The thesis of Allium is that we can achieve velocity through clarity of intent.
And you're also saying that there's a space, a gap in the design space between the flexibility of human language and the detail of programming language, then?
That's a nice way of putting it. And is it between human language and a programming language? I say what it's between is human language and, perhaps the most rigorous specification language, TLA plus, for example, which is going to provide you with formal guarantees of correctness. Allium sits in between those two kinds of things. We can't offer formal guarantees. We're living inside the LLM. We're therefore subject to that kind of semantic, kind of metaphorical similarity rather than symbolic correctness. We do have command line tools and other things that will check the validity of syntax. But even so, we're in between those two extremes. We're more rigorous than prose, but yeah, we can't offer the formal guarantees of TLA plus. However, it is a programming language in the sense that it's got very well defined semantics. You are describing exactly what you want to have happen, and so in that respect, it's not inconceivable that in the future there could be an actual runtime for Allium. And one of the directions that we're moving towards is to make sure that we capture enough information to be able to implement property-based testing, for example. And so we're sort of moving in that direction. And in spite of the fact that we are, we're LLM native, it's important to me that it is a very well-defined language with clear rules about its use. Even though we can't guarantee the LLMs will always follow them to the letter.
Yeah, but you couldn't guarantee that about human programmers either. So what kind of things can I specify concretely? Can I say, like, this project should use OAuth and support Google? This project should save all data persistently to Postgres, a durable database? Can I say your thing of the P99 for response time should be less than 100 milliseconds?
You can specify all of those things because there's an implementation guidance section for every rule in the specification provides the ability to use human language as well. And so there's nothing that you can't put into your specification. You can add non-functionals. You can say, I'd like to use Google's OAuth. You can say, I'd like to use Postgres. That's not the core objective of a behavioral specification, though. What we instead want to talk about are the domain entities that we're operating on, what their attributes are, for example. So we're not going to implement the schema that ends up in the database, but we are going to say, we've got customers and line items and we've got quotes and so on. These are the things that our system knows about. You're going to have rules that describe how transitions through your system work. There are going to be preconditions, postconditions, triggers. Surfaces is something that gets specified as well. So those are intentionally not talking about a web page or a CLI interface or an API. It's simply a surface. It's a way that the outside world can reach your domain. And so surfaces expose the things that the outside world can read, and the things that your code requires those people, those actors who are interfacing with your code to provide. But it's intentionally expressed in this quite abstract way because we don't know, is this an API or is it a rich web front end? We don't really want to, because the same behavioral specification could be used to drive an implementation of both of those things. And so when you're asking your LLM to implement, you're going to have to, well, ideally, you're providing some kind of additional context, which is going to talk about your technology choices and those kind of non-functionals and other things like that. Otherwise, you're going to get, some kind of default choice. As we said, it's probably going to end
It's
up
going to
being
be
Python or
TypeScript or the REST API, right?
Yes. Yeah, that's right.
This sounds like you're describing a language for business logic, then.
Well, so in a sense, yeah. So kind of state machine-y transitions is a key part of it, for sure. I mean, that's a lot of what systems need to do, isn't it? It's manage manage interactions with data and ensure that they're correct.
Absolutely, yeah. I'm just wondering, I mean, after we finish this discussion, I'm going to go and run it on one or two of my existing projects. I'm wondering what will be distilled out of it. Like, will it boil out some of my hard external requirements, or is it going to boil out what my core business logic is?
Mm-hmm. Well, it's fascinating, isn't it? There's inherently a judgment to be made about level of abstraction. Because if the specification ends up being too close to the code, it's not really adding anything. If it's much too high level, of course, every website's the same. I go and I make a request and I get some data. That's not useful. So part of the skill is around, and I mean this in the sense of markdown skill.
Oh, right.
The way that we guide the LLM is to make a sound judgment based on kind of senior engineer type expertise about what the right level of abstraction is. Of course, you can always guide that in the prompt that you provide along with your distill request. But our experience is the default is really good. And we've used it to find bugs in existing code. Because in producing a behavioral specification that's attempting to communicate the what of your system as well as the how in a kind of compressed way, because a spec is normally somewhere between 5 and 50% of the size of the code, depending on how complicated your semantics are or how verbose your programming language is.
Right.
So it's always introducing some kind of compression. And then by comparing the specification against your code, you can start to go, oh, that's funny. That code's quite complicated for the specification that has described it. I wonder why that is. Perhaps the code's doing more than it should. Perhaps there's some kind of tangled intent going on there. And so although you can never say for certain that the code is wrong or the spec is wrong without getting your hands dirty and taking a really close look, it provides this kind of topology of your code that allows you to sort of go and look at the areas where you might find something that's wrong. And as I say, we've used this to discover bugs in code that people were using very happily, they weren't aware of. And so it really does add value and is part of this story about how I think LLMs can introduce more rigor to software engineering than we've had to date.
Yeah. I wonder if you're going to... So I've done a thing with a few projects where I've run an agent over the code base and said, well, draw me some mermaid diagrams, right? So that I can try and visualize what's going on. It does quite a good, it does quite a good job. And sometimes I've looked at these diagrams and thought, well, that's not right. That doesn't seem like the architecture I'd want. And trying to prompt for it to re-architect things the way the diagram should have come out. Are you finding that with Allium? Are you going to be doing that where you distill out spec files for a system and look at them and expect a human to read through them and find actually contradictions, change the spec and have the LLM re-project it back into the code base?
I mean, the shape of that way of working is correct. But again, the specification files themselves are you can look at them to check individual rules, but I don't think anyone will look at a whole file and attempt to know whether that file describes the whole behavior that they want from their system. That's a lot to try and extract out of potentially a long file. But for taking a look and checking that, oh yes, the right attributes are being exposed from my domain entities here, or yes, that rule has the right preconditions and it triggers the right thing. Those kinds of things, for sure, you could have a domain expert look at. But I think for the kind of workflow that you're talking about there, the conversational one that we're all getting used to with our prompts is where people are right now, and so kind of Allium's designed to work with that. What it tends to create is this dynamic where the LLM is asking you really sharp questions about, what did you mean when you said that? Or, I've noticed that this part of the specification, that part of the specification are, slightly inconsistent. What do you want to do about it? So kind of, there's a sort of Sapir-Whorf kind of quality where, that theory that the language that you use describes your reality. I think by teaching the LLMs about this structured language of behavioral specification just puts it in that frame of mind where those are the kinds of things it's asking about, and it's really powerful. And I'm constantly surprised by the quality of the conversation that we have and how quickly you can get to a really good description of the problem space, having been told about the potential ambiguities and conflicts and edge cases that you might always just have shrugged off before because it was a bit, you weren't really aware of them. Maybe your sense was they might pop up, but there are more important things to worry about right now. The Allium skill, teaching an LLM to patiently, in a kind of Socratic way, work through these things with you, makes it almost pleasant, because again, this the speed that you can realize means that it can be quite intense to be being asked in quick succession lots of very detailed questions about how your system should behave. But an hour or two later, and suddenly those problems are solved. And maybe an hour or two after that, you can see the system actually running. It's very rewarding.
Right. So I've got the wrong end of the stick with this language. I thought it was a language for us to use to drive the LLM. But really you're saying it's a language to help the LLM pin down its own thoughts, ready for when it talks to us.
I think that's a great way of phrasing it, yes.
Right. Okay. So I've got to go and try this and see what the results
I hope you
are.
will.
That's the only way I'm going to... how do I get started? Give me that beginner's guide.
So it's open source. It's on GitHub. You will find it at /JUXT/Allium. And it's very easy to install. It is just a set of Markdown files. There's a Claude marketplace interface. So even within Claude, you can do /plugins and add the JUXT marketplace and grab it that way. Or if you're using anything else, there's a sort of NPX skills installation as well. It's all described on the README. Once you've got it available in your LLM of choice, just type Allium, and it will take a look at your code and probably ask you, do you want to add some features? Do you want to distill a specification? And away you go. You're immediately in that conversational interface, informed by the kind of behavioral specification language.
Okay. I've got a couple of projects, one that's been going very well and I'm curious, and one that's been going a little bit badly, and maybe I could use some assistance on it. So I'm going to go and try both.
How that goes.
And I'll put the links in the show notes once I've done it. Henry, thank you very much. That's interesting. Pinning down an LLM's thinking. I like this. I really like this. I'm going to give it a go. Henry Garner, thank you very much for joining me.
Thank you. My pleasure.
Cheers. Thank you, Henry. So I did try Allium on one of my projects, by which I really mean I downloaded the skill files and said to Claude, go on then. And it did actually work. It found a whole bunch of corner cases in the design, like genuine problems that I hadn't thought to think about. It found unknown unknowns. And then I tried it on a couple of other repos, and it did it again. And then I tried it on a friend's repo, and it worked for that. So, yeah, genuinely, I think he might be onto something. I haven't tried it for a long run. I haven't tried it over 6 months, but there is something here. So give it a whirl if you're interested. You'll find the links, as ever, in the show notes. And while your agent is processing them in the background, please take a moment to like, rate, and share this episode. And make sure you're subscribed, because whatever the future holds, we'll be back soon with another interesting mind from the world of software. Until then, I've been your host, Chris Jenkins. This has been Developer Voices with Henry Garner. Thanks for listening.